Okay, this is a typical biofil digester. This is one of the many designs of a biofil digester. At this stage, the design has already been done for this particular site. Like each site varies depending on how the foundation is being laid. If you can see, look closely. You see, this particular digester was dug 2 feet down, and over here, the second is well done. So he is the engineer and the founder of KenSparks Biofil Digester. It's a company recently established in Nigeria that deals purely on building sustainable, affordable, flexible biofil digester that fits every household. So it doesn't matter whether it's in the mainland or in the island, he's here to deliver. Mr. Ken, so I'll be asking you 1 or 2 questions about this particular digester that you made. So what do you have to tell us about this digester?
It's a particular design because we have different designs, and what we consider when we come to build one for one, we consider the foundation of the building, and we consider the piping. Then secondly, we consider the sand, kind of the filling they use to make the sand, and we also go down to the water table and find out how deep is the water table, because here is an island. So we ensure that we don't hit the water table. So because of that, we don't go beyond 2 feet down. So 2 feet is enough, and the piping coming out, we ensure that it's deep enough to connect to the piping of the plumber that will connect to the toilet. So this particular one is a 2-chamber, which is the toilet chamber, water digester. So when we finish it, this is just a process. When it's done, when the physics is dropped, there's a lot of things that we use for servicing, which is the servicing of the digester to ensure its function. So once it's done, when physics drop, there's something we put inside that separates the physics from the water, and the water moves to the water side, and the ground, because we did not hit the water table, the sharp sand that is used to fill the land quickly digests the water to get to the ground. And we ensure also that we don't build it where the borehole of the house is. So we give a very far distance. Like the borehole of this house is behind the house, so we built in the front. These are a little consideration that we make to ensure that what we deliver will be effective, efficient, and also environmentally friendly, not to breach any environmental law. So this digester will serve as long as, which means the maintenance will come maybe after 20 or 30 years, which means the owner of this house wouldn't have to draw toilet out of this thing for the next 20 or 30 years.
20?
Yes.
Wow.
As it is now, and thereafter, what we can do, and thereafter would be to come and servicing is just to remove what is inside and then change it again, because every physics will be broken down to sand, while the water is digested into the ground. The ground drinks up the water. So it does not also cost any of it, because the water is treated by things we use to treat the system. So
this little thing now that I think we are all seeing, it can last for 20 years.
Yes, without being filled. Without being filled, exactly.
So how does it work? Because if you are separating the sand from the physics, right, where does the water go to?
All right. What happens is that immediately somebody excretes the water of the physics. There are fibers we put inside, and we use chemical that breaks down the physics and also grows bacteria that are meant to eat the physics. So immediately somebody drops a physics, what happens is that within 2 days the physics is turned to a sand, and just a little sand that is dropped into it. A little sand. While the water immediately moves away, and the earth drinks the water. The earth drinks the water. Because we did not hit water table, we also provide extra pipe on our side in case there is a water table comes up, so that the pipe outside can also be picking the water that is coming out and also be dropping it gradually until the water table goes down again.
Okay, Mr. Kenneth, help me throw more light in this water table. Are we in water table? What is
water table? Means that base that we're island.
Okay.
Water is beneath the ground. If you dig here far now, we're inside the river, you get water. And because of that, water table is where the water is beneath the ground. So there is a filling that's gone. So we are building within the filling level to ensure that it doesn't meet the water in the ground.
Okay.
So, and when the physics water goes out, the sand that used to fill the compound drinks the water.
It drinks it.
So just as when you pour water on the ground, the air drinks the water.
So you going 2 feet down, not more than 2 feet down, is to ensure that you don't go beyond the filling that has been done on the land already.
Exactly.
Interesting. Okay.
Exactly. And the physics itself turns to sand within every 2 days,
So
which means it doesn't get filled.
So that means, like, imagine you piling up this amount of sand now into the digester. It takes 10, 20 years
to get filled, because what will be throwing just a little sand, and also as you're flushing, the sand is also still moving to the water side. It's also flushing the sand. So it's difficult to get filled.
Okay.
I've personally used it for more than 12 to 13 years in my own house, so it has not been filled to this day. So it's effective, efficient, and in all third world countries, this use, you find it in Ghana, in Asia, in India, in Pakistan. It's new in Nigeria, but most African countries and Asian countries are using it. This has been in system for centuries, just that Africa started using it
late.
I think 15 years ago.
Okay, Mr. Kenneth, we would love to see more of this design. This is the first stage, right?
Yeah.
Okay. So, thank you so much.